This is Mr. Parvez with Henrico High School. Today we're going to look at forces and talk about what forces we need to take into account when an object is sitting on a flat surface. The next lesson we're going to talk about objects on an inclined surface. So currently we have a box and that is sitting on a flat surface, and this box is going to have a mass. The mass of this box will be in grams, kilograms, micrograms, whatever you want it to be in, but just keep in mind that it's always best to convert the mass to kilograms. So we're going to call this box M1. The mass of M1 can be anything. Mass of M1 can be 2 kilograms, it can be 3 kilograms, 4. So for right now I'm just going to make it 4 kilograms. So the first force you should always draw that's impacting the box is the force of gravity. And the force of gravity is pulling this box downwards towards the center of the planet. The force of gravity is always down towards the center of the planet. So I'm going to draw an arrow depicting the force of gravity on this box. And the force of gravity is downwards, and it's a vector because it has a magnitude and a direction. Magnitude just means number, a measurement, and direction is up, down, right, left, or at an angle theta. So currently this box has a force of gravity that's pointing downwards. And how are you going to calculate the force of gravity? Well, the force of gravity is calculated the way you calculate any force. You calculate it by taking the mass of the object and you multiply it by the acceleration that's impacting that object. In this case, the acceleration that's impacting the object is the acceleration of gravity. So you can write it as an A if you'd like, but most professors and most students prefer to write a G in there. And for G, you can choose to put negative 9.81 meters per second squared, or you can round it to negative 10 meters per second squared. I'm going to round it to negative 10 meters per second squared just to make my math easy. So the mass of this object is 4 kilograms, and 4 kilograms times 10 meters per second squared comes out to be 40. And the units for force are going to be newtons. If your mass is in kilograms and your acceleration is in meters per second squared, then the derived unit from there is newtons. So this will be 40 newtons. So this tells you that the force of gravity is trying to take the box straight down. And if the floor wasn't present, the box would go straight down. So the floor is actually preventing the box from going down. So that means that the floor is exerting a force on the box in the opposite direction. So the floor ends up exerting a force in the opposite direction on this box. And we call that force the normal force. Any force that a surface exerts on an object in response to the force that the object is exerting on the surface is called the normal force. Another way of looking at it is this. If there's a force on an object and it's trying to push the object down, but the object doesn't go in that direction because there's a surface present preventing the object from going down, then that means that the surface must be exerting an equal and opposite force, or a force in the opposite direction that is countering the force that's trying to take the box down. We call this the normal force. So any force exerted by a surface is called the normal force. In this case, the normal force is going to be exactly as strong as 40 newtons to keep the box in equilibrium on the vertical axis. So here's your vertical axis, right? Your y-axis. This box is in equilibrium because it's neither going down or up. So that means both forces are just as strong as each other, except they're in opposite directions. So this one will also be just as strong as the force of gravity. So you can write it as m times g, or you can plug in 40 newtons. Now, one thing keep in mind, it's always good to put pluses and minuses for direction. So upwards should be positive, the downwards should be labeled as negative. Just like over here, the acceleration of gravity should be labeled as negative 10 meters per second squared, and so it comes out to be negative 40 newtons. So these are the two forces that should go on your diagram immediately. The next force could be any force that's acting on the object. So let's say you have a force that is trying to move this object to the right. So there is a force that's trying to move this object to the right. We can call it F1, we can call it FA for applied force, whatever you want to call it. I'm just going to call it FA for applied force. So let's say there's a force to the right that's trying to move this object and it's 50 newtons strong, but the object doesn't move. Well, if the object doesn't move, that tells you right off the bat that there must be another force on this object preventing it from moving. And that force is the force of friction. Now, force of friction exists between the surface and the object. There are rough surfaces, there are smooth surfaces. Rough surfaces generate larger friction, smooth surfaces generate less friction. So in this particular case, the force of friction is pointing in the opposite direction. And I'm going to put it in a different color. I'm going to put it in orange. So the force of friction is pointing towards the left. and the force of friction is just as strong as the applied force in this particular case, because the force of friction is keeping the box from moving. So the force of friction is to the left, and I'm going to say it's just as strong as the applied force 50 newtons. That's why the box does not move. If the force of friction isn't as strong as the applied force, then the box is going to accelerate to the right, because there will be a net force. So for example, let's say the maximum force of friction that could be exerted by the surface on the box is not negative 50 newtons, but let's say it's negative 40 newtons. If that were the case, then that means then the box has a net force on it towards the right. 50 newtons is greater than 40 towards the left. So the net force on this object would be 10 newtons to the right. The sum of the forces in the x direction, this symbol just stands for sum, and the forces in the x direction are 50 newtons minus 40 newtons. So the sum of the forces comes out to be 10 newtons. So there is a net force of 10 newtons that's pushing this object to the right. So the box will end up accelerating. And how would you calculate the acceleration? You'd simply go to Newton's second law, F equals ma. For your F, you're going to plug in 10 newtons, because that's the net force on the object. For your m, you're going to plug in 4 kilograms, and you're going to solve for your acceleration. 10 divided by 4 is 2.5. So this object is going to accelerate to the right at 2.5 meters per second squared. So you could tie kinematics equations and questions into this by saying, okay, if this object is accelerating to the right at 2.5 meters per second squared, what will its final velocity be after 3 seconds? So a question could be that after 3 seconds, what is its final velocity? So you would say, well, I know that the initial velocity, because this object started off from rest, the initial velocity is 0. I know that the acceleration is 2.5 meters per second squared. And I can solve for my final velocity simply by using one of my kinematics equations. Final velocity is equal to initial velocity plus acceleration times time. So your initial velocity is 0, your acceleration is 2.5, your time is 3 seconds, multiply the 2, and you're going to get your final velocity of this box. So you can tie in these units from the end of the second 9 weeks to the beginning of the second 9 weeks, or the first 9 weeks. You can tie them in right and left, as long as you understand the nature of these ideas. So today we discussed the force of gravity, the normal force, an applied force, and the force of friction. A couple of things you want to keep in mind: that the force of gravity on an object is the same thing as the object's weight. So if a problem says that the object's weight is 40 newtons, right off the bat they're telling you mass times g is 40 newtons. So they're telling you that the force of gravity is 40 newtons. Remember, the weight is the same thing as the force of gravity. It's not the same thing as the mass. It's the same thing as the force of gravity. Force of gravity is mass times the acceleration of gravity. So that's one thing you want to keep in mind. Another thing I'm going to go a little bit in detail about is what defines the force of friction. So we introduced the force of friction over here. Well, what are some things that impact the force of friction? Well, if you were to do any experiments with the force of friction, you would realize that the surface impacts the force of friction. If it's a rough surface or a smooth surface, it's going to tell you how much friction is being exerted on the object. So for a rough surface, there'll be more friction. For a smooth surface, there'll be less friction. So the roughness and the smoothness of a surface is defined by something called the coefficient of friction. The coefficient of friction. You have two types of coefficients. Let me correct this. There are two types of the coefficient of friction because there are two types of friction. Coefficient of friction. And the two types of friction are kinetic friction and static friction. Kinetic friction is when an object's moving, it's sliding on a surface, then you have kinetic friction. Static friction is when an object is at rest, you're trying to move it, but friction is preventing it from moving. So the two types of friction are static and kinetic friction. Static friction is stronger than kinetic friction. Static friction is impacting the box when it's at rest. You're trying to move it, but it's not moving. Kinetic friction is when you've gotten the box to move, now you're going to keep it moving, but yet there's still friction between the box and the surface. So you have two types of friction, and thus you'll have two types of coefficients of friction. They'll be static and kinetic. And you can label them by putting a K in the subscript for static when an object's sliding, or you can put an S for a subscript under the coefficient if the object's at rest. The other important thing you have to take into mind to calculate the force of friction is the normal force. The normal force is how much the surface is pressing against the box. If the normal force is very high, then that means that the surface is pressing against the box with a large force. That means there's going to be a lot of friction. However, if for some reason there was a string pulling this box up, not enough to lift the box up, but still there was a string pulling the box up, then that means the box doesn't press against the surface as much, so the normal force would be less, because the surface wouldn't have to press back against the box as much. So the normal force impacts the force of friction. So the equation for force of friction is the coefficient of kinetic or static friction times the normal force. That's one of the simplest ways to calculate the force of friction, but remember, force of friction can be calculated a number of ways. It can also be calculated if you know the mass of the object and you know how much acceleration the force of friction is exerting on the box. So if, let's say, this box was moving and then friction starts impeding its motion and starts to slow it down, that means it has a negative acceleration on the box. Friction causes a negative acceleration on the box. That negative acceleration times the mass of the box can give you the force of friction also. Either case, remember, the force of friction is a force, and so the final units for the force of friction will be in newtons. The next lesson, we're going to talk about an object on an inclined surface and how does the force of friction come into play. Maybe in the third lesson or the fourth lesson, but we're going to build on these ideas.